Okay, we're going to briefly cover 1.5. The first part, again, this should be a review, is just to solve a linear equation, right? And so the steps are in the notes. I'll kind of just walk through it with an example problem. So the first step when you solve a linear equation, and again, linear means that the variable is just to the first power. It's not quadratic. There's no x squared in this. First step is simplify each side of the equation, and to do that we distribute if we need to and combine like terms on each side. Okay, so if I do that, I'll go ahead and distribute, and I'll have this by 4 times x is 4x, 4 times 7 is 28, and so forth. Distribute the right side. Well, the left side can still be simplified. I can combine the 28 minus 2 is a 26, and so I combine those together, and now both sides are simplified. Worst case, you're going to have a variable and a number on each side. You may only have one variable on one side, but this is kind of the worst case where you've got both numbers and variables on both sides. So step 1 is complete. Step 2 is you want to go ahead and move the variables to one side of the equation, the numbers to the other, using only addition and subtraction. So I'll go ahead and move the variables to the left side. So to get rid of a negative 6x, I will add 6x because that adds up to 0, so that x term is gone. On the left, I have to do the same. I add 6x. I end up with 10x plus 26 is equal to a negative 18. Since I chose the variable to the left, that means the numbers have got to go to the right, so I'm going to get rid of the negative or the plus 26 by subtracting 26. So when I do that, 26 disappears on the left, but I subtract 26 on the right, and then end up with 10x is equal to negative 44. The last step, if you have a number with your coefficient, you go ahead and divide both sides by that number. So 10 divided by 10 is a 1. 1 times x is x. And then I have negative 44 over 10. So my answer is negative 44 over 10, which you can reduce by dividing by 2 to negative 22 over 5. Okay, so those are the steps. Simplify, move variables one side, numbers to other, and then divide out your coefficient. You can check your answer by plugging it back in, but that'd be a little bit of work. It's probably easier in this case just to check that you did it correctly. One thing I want to highlight, because we're going to be doing this, is solving inequalities. The only difference between an equation and an inequality is we replace the equal sign with either a greater than, less than, greater than or equal to, or less than or equal to. So for example, if this had not, instead of an equation, let's just say it was greater than or equal to, then I solve it exactly the same way. The only difference is that this inequality symbol would follow through, and so my answer, if it had started as a greater than or equal to, would be x is greater than or equal to a negative 22 over 5. I'll talk more about inequalities in a minute, but the process of solving an inequality is exactly the same as an equation. Next, I want to talk about solving equations that have fractions in them. You don't want to keep the fractions in there. You can, but it makes the problem much more difficult. So your objective should be to get rid of it. So here's an equation with 3 fractions in it. And again, when you want to add and subtract fractions, you have to have common denominators. So you'd have to determine a common denominator and then change all these fractions to common denominators and so forth and so on. And it gets a little bit tedious. The easier thing to do is just get rid of the denominators. So the way you do this is you take a look at all the denominators and ask yourself, what is the lowest common denominator? Or what is the least common multiple? In other words, what is the smallest number that 12, 6, and 2 can divide into? Well, it can never be smaller than the biggest number, right? Because this has to divide into it. So obviously 12 divides into itself, 6 can go into 12, 2 can go into 12, so 12 would be the lowest common denominator. So it's always going to be the big number or a multiple of the big number. So what do I do with that? Well, an equation, as long as I do the same thing to both sides of an equation, I can do whatever I want. So I'm going to use my lowest common denominator, and I'm going to multiply both sides of the original equation by 12. Okay, so this will not change the overall equality because I'm treating both sides the same. Well, if I do that, I end up having to distribute the 12 over here. So the net effect is every single term gets multiplied by 12 when I distribute. So it looks like this. So every term, whether or not it's a fraction, if this had been a whole number, you're still going to multiply it by 12. Everything gets multiplied by that common denominator. And when I do that, we're going to get very nice cancellations, because when you multiply fractions, right, you can cancel out common factors. Well, the denominator will always be a factor of this common denominator that you're multiplying by. So you divide your denominator by itself. So in this case, 2 divided by 2 is 1. And you divide the 12 by 2 and you get a 6. And then 6 times 1 is 6. So you end up with just a 6x. Moving over here, well, 6 can divide itself. 6 can go into 12 2 times. 2 times 1 is 2. Equals, and then over here, well, the 12 just cancel each other out to 1s. 1 times 7 is 7. And now you have an equation with no fractions. Okay, so this may look like a lot of work, but if you pick the lowest common denominator, you're always going to have the denominator divide into that common denominator, which effectively eliminates all the denominators. And then, of course, you can just solve the equation as we discussed before. Here's an example from the worksheet of, it looks just a little bit different. You've got this binomial, but it's over a single number, right? Minus 4 is equal to, again, a binomial over a 3. So you look at all the denominators, 2 and 3, so the lowest multiple is going to be 6. 2 doesn't go into 3, and 3 is the bigger number. The next multiple of 3 is a 6. 3 goes into 6, 2 goes into 6, so 6 is your lowest common denominator, or least common multiple. So I multiply everything in the equation by 6, whether or not it's a fraction. So 6 will multiply the first term, 6 will multiply the second term, and 6 multiplies that term on the other side. I'm going to get a cancellation. My 2 here can divide into 6. 2 into 6 is a 3. So I end up with a 3 multiplying what remained up here. So this 2 canceled itself. 2 into 3, 6 is 3. So that's where the 3 came from. 6 times 4 is 24. The 3 over here divides itself. 6 divided by 3 is a 2. And this is where the 2 will now multiply what's left in the numerator. And then from here, it's just an equation. I'm not going to go through the whole thing. I would then distribute, combine like terms, then move variables to one side, numbers to the other, and get W is equal to a 10. Another way you may see a problem involving fractions written is like this, where you have the fraction multiplying something in parentheses and a fraction multiplying something in parentheses. And normally you go, well, let me just go ahead and distribute, and you could do that and then eliminate the fractions. But before you do that, just understand that if I multiply something in front of this, should be something times 1/3 times y plus 10, you can do the elimination of the fraction before you distribute. So for example, if I had 2 times 4 times 8, if I distributed the 4 to the 8 first and got a 32, then 32 times 2 is 64. But notice, since it's multiplication, I could do it straight up in front first. 2 times 4 is 8. 8 times 8 is 64. So the easier thing to do is just to eliminate the fraction before you distribute. So here the LCD between 10 and 3, the first multiple of 10 that 3 can divide into is 30. So you multiply by 30 before you distribute, and then you're going to get a nice cancellation. Well, 3 divides itself. 30 divided by 3 is 10. So there is your 10 from this. And over here, 10 goes into 33 times. So when you do the cancellation, you end up with a 3. And then you got a simple equation. Now you can do your distribution. Right, I'm not going to go through the whole thing. Variables to one side, numbers to the other, do your division, and then you get an answer. Okay. Bottom line, get rid of the fractions by multiplying by the lowest common denominator. Next, I want to talk a little bit about inequalities. Okay, I've already discussed that when you solve an inequality, you solve it the same way that you solve an equation. So I'm not going to go through that. But at the end, when you solve an inequality, you're going to get an answer something like this. Let's just say the answer is 3 and I'm doing all the variations. Then you should be able to sketch the graph because it'll be very helpful to put this into what we call interval notation. So for example, this would be read as x is greater than 3. Okay, so the 3 is not included. It's everything greater than 3. So when we graph that, you might have in high school had open circles or closed circles, but here we're going to use a parenthesis, an open parenthesis in the direction that the line opens to indicate that the 3 is not included. Okay, as opposed to if it was x is greater than or equal to 3, where the 3 is included, then in the graphing in the interval notation, we put a square bracket that opens in the direction that the line goes. So open bracket, open parenthesis, if it's not included. If it's included, it'll be a bracket. Likewise, x is less than or equal to 3. Okay, it is included. I'm going to put a square bracket facing the direction that the line moves in. If it's just strictly x is less than 3, that means it's not included. I just simply put a parenthesis facing the direction the line moves. Now, interval notation, which is how you're going to have to answer most of these questions, this will be what you get mathematically, but you will often have to answer it using this interval notation. Interval notation is very easy if you sketch the graph, right? Because every graph you're going to have, every graph has a left side and a right side. And so you take a look at this and you go the leftmost part of this graph, since it opens to the right, the leftmost is a 3, and the 3 is not included, so I put the parenthesis there. Then you do a comma, and you go, what is the right side of the graph? Well, this particular graph goes on forever. It never stops. That's infinity. And so you put an infinity symbol, and then infinity always gets a parenthesis. You cannot bracket something that goes on forever. Okay. Likewise, if I had to write this answer in interval notation, well, here's the graph. My left part of the graph is a bracket on 3. The right part of the graph goes off to infinity. Infinity always gets parentheses. So this answer produces that interval. This answer produces this interval. It's easier to write the intervals often if you just sketch the graph. Likewise, x is less than or equal to 3. We can see the left side of this graph is off to negative infinity. And then the rightmost part of the graph, it stops and includes the number 3. So the 3 gets a bracket. You can see the bracket is opening in the direction that the line goes, in this case to the left forever. Likewise, if x is less than 3, here is the graph. The left side, this should be, it looks like an 8, but that's infinity. So it'd be negative infinity on the left, and it comes up to 3, but the 3 is not included, so it gets a parenthesis. Okay, so this is interval notation. Infinities always have parentheses. The only determination is bracket or parenthesis. Bracket includes the number. Parentheses do not include the number. It's always the left side of the line, the right side of the line. Okay, and the bracket or parenthesis with the number will open in the direction the line goes. One thing to be careful of is if you solve the equation or the inequality and your variable is on the right, you may tend to write this backwards, right? You may read this as 3 is less than x, but that's going to be confusing because when you say less than, you're going to be thinking it's going to go to the left. Always read it from the variable to the number. So x is greater than 3, or you can rewrite it. You just keep it, the x in the open side, the 3 is being pointed to. So these two are exactly the same. This opens to the right, like this, to infinity. And the interval notation would be 3 to infinity. But if you just looked at this, you may have an inclination to graph it going in the opposite direction because you're reading it from the number to the variable, not the variable to the number. So be careful there. One other thing that you have to be aware of with inequalities, the one thing that you have to just be on the lookout for, is what happens when you divide or multiply by a negative number. Okay? And to illustrate why this happens, for example, here's an inequality, 2 is less than 4. That's true, 2 is less than 4. If I multiplied both sides by a 2, I would end up getting 4 is less than 8. Okay, that's still true, right? 4 is less than 8. But notice if I multiplied by a negative 2 on both sides, so I introduced multiplication by a negative number, now I have negative 4, negative 8. Well, negative 4 is not less than negative 8. Negative 4 is greater than. So notice that when I multiplied by a negative number, it flipped the direction of the inequality. And that just has to do with the fact that in a number line, the relationships with negative and positive numbers, these numbers, the bigger absolute values go to the left on the left side of the number line from 0. The bigger absolute values go to the right in the positive range. And so when you divide or multiply by a negative, you're going from one side of the inequality to the other where the relationships flip. So in order to be correct, you have to change the direction of the inequality. So this will show up normally something like this. You do all your work, you get it down to the last step, and you go, well, here I've got to divide this by a negative 2. So I have introduced division by a negative number, okay? And so that's my key that I'm going to take my answer, but instead of leaving it greater than, I'm going to flip it in the opposite direction and make it a negative number. So now x is less than negative 4. Now notice the difference here. That's a negative number. If I divide both sides by 2, the fact that that's a negative number, that this is going to be a negative answer, isn't the point. The point is I did not introduce division or multiplication by a negative number, so this would remain greater than. Okay, it's only when I introduce that negative division or negative multiplication that the direction of the inequality is going to flip. And finally, the last thing, that inequalities can be compound. So an AND inequality is a situation where both conditions have to be true, and they're often written like this, where you've got your variable in the middle and it's bounded on each side. And so the way you solve this is you're really solving two inequalities at one time. If you want to isolate the x, then I got to get rid of the 2, so I'm going to subtract 2. But I'm going to subtract 2 from both sides because I'm really doing two equations or inequalities at the same time. So to isolate that x, I subtract 2 from both sides. That gives me a negative 1 here. That leaves me just the x. And then over here, 5 minus 2 is 3. And the way you would read this is x, always from the variable, x is greater than a negative 1, and x is also less than 3. So if you take a look at the way that the interval notation would work, you go, well, the left side of this, x has to be greater than a negative 1, so it's bounded on the left by negative 1, but it also has to be less than 3, so it's going to be bound on the right by 3. And so you can see that this produces this interval. It's everything in between negative 1 and 3. Okay, the only other compound inequality is called an OR inequality, where either condition can be true to be a valid answer. So these will always have just two different inequalities, right? So all you do is you solve each of them individually. So you can see here's the solution to the first, here's the solution to the second. If I had a single graph and I was to graph each of these intervals, well, x is less than 2. So if that's a 2, I'm going to open the parenthesis. That's going to go off to the left forever. That interval is represented in interval notation right here. The other inequality, when I solve that x is greater than 3, well, on that same graph, if this is 3, it's going off to the right forever. Well, here is the interval notation for this portion of the graph. So anywhere here and anywhere here, it's a valid answer. it's not going to be valid in between because there's no line there. But the way that I join these two intervals together is this big upside down U. It's called a union symbol, okay? And you'll see it on your palette. If you have to type one in, it's not a keyboard U. It's going to be a special symbol U. Stands for union. So or inequalities get joined with a union symbol, and inequalities typically be bounded on both sides. Okay, so that should be the all of 1.5.